Hello guys, welcome back. So in this video we are going to understand this second question, that is a count path with a given jaw value, right? And that is we have here. You can see the question is saying that you are given a 2D integer array grid with size m cross n, and you are also given an integer k. So our task is to calculate the number of paths that we can take from the top cell 0 0 to the bottom cell m minus 1 n minus 1, right? So there is a grid, you can say a matrix we have given to the array, and from the starting cell, top cell, you can say 0 0, index 0 0, we have to come to a cell, let's suppose m minus 1 n minus 1, the last you can assume, or anyone else. So we have to satisfy the two constraints here, two conditions we have to satisfy. Either we have to move right or down. Formally we can say for the I and j cell, I and j plus 1, or I plus 1 and j, means right side and down side, right, if the target exists, right? And then we have to do jot of all the numbers on the path must be equal to k. So we also have given k, and we have to do the jot of all the numbers that is on the path, and then we have to, it should be equal to k, and we have to return all those number on such path that is equal to the jot. We have to return all those numbers, right? And there is a condition saying that the answer can be very large, and so we have to take a result modulo, right? Result modulo we have to take 10 to the power 9 plus 7, means 1000 something, 10 lakh something it will come, right? 10 crore, sorry I'm sorry. Okay, and you can find, right? You can, what you can do, you can write like this. So you can see this is the number, I can say I have also seen this one. So it will come around this these things, right? The number, it will come like this. So it is the mean of that 10 to the power 9 plus 7, right? Leave it that we have to take our modulo. So I think you have you understand the question, right? And definitely you will going to understand the answer also. Okay, so let me zoom a little bit. Okay, so first of all, the code that I'm going to show you is a recursive depth first search, and the solution we have taken as a memorization to solve the problem of finding the path in a grid, because the result is a specific jot value we have to do calculate, and then that we are talking about 10 to the power 9 plus 7, we have to take the mod also. So this is or you can say the main concept of this problem is we have to first think about recursive DFS with the backtracking, and then we have to create a function. Let's suppose DFS function will create, and the function we have to traverse the grid recursively, you can say, right? So what we have to do, it will explore the two possible moves at the every cell, down and right? And then what we have to do, we have to also memorize, we have to use the memorization, right? So that if, let's suppose, if there is a 3D array, like if there is a dp of I, dp of j, and the jot value, right? Because there will be 3 combinations of the value on in this grid, because every time we have to also think of the jot value, right? So it is used to store the result of sub problems to avoid, you can say, the redundant calculations. So basically I'm just here providing you this thing, because I'll explain you in another video also, but just think for now here that let's suppose we have a 3D array, right? And the 3D array will take dp of I, dp of j, and this jot value, right? Why? Because we have to do memorization, and we have to store this value to, we will keep storing this value on this dp, because we have to store this result of the sub problem, so that we can avoid the redundant calculation, repetitive calculations we will not do, right? And so that we will store this value, right? And so this value like dp of I, j, and zor value, it will hold the, you can say, number of valid path from cell I, cell ij, I comma j, you can say, with the like any current jot value that we have given, right? So if this is I and j, right, and this is your value, so for this I and j, right, from this cell I and j with the current job value that we have here will hold, right, this will hold the number of valid path from I to j with this current job value, you can say, right. And then job calculation will do what? At each cell the job value is updated using the current cell value, right. What we will do, we'll make a job, and then we'll keep checking the value, right. So the job value will keep job calculation will do what? We have to do make the job function calculations, you can say, and at each cell the job value is getting updated because of this line, and so we will update the current cell value with this one, right. And this is the base condition we have taken, so that if the indices go out of the bound, right, let's suppose if I is less than 0, greater than j, and j is less than 0, right, and I is greater than equal to m, in that case it should return 0, right. So if the destination cell is m minus 1, n minus 1, so it will reach to the that point, and the job value will be equal to k, so it will return 1 in this valid path that we have found, right, and so it will return, right. So these are the conditions that you have to think of, right. It should not equal to minus 1, it should not equal to this should not equal to these things, means I should less than not 0, 0 should not be less than j, like that. So this condition will return 0. If this is equal to minus 1, means current value of the job with respect to this dp I and j, it is, if it is equal to minus 1, will return that value, right, means some value is there. In other case, if the value is equal to job of the value, right, and now we have reached to the last point, let's suppose, so in this case we will return 1, because this is the valid path that we have found, right, because if the destination cell we have m minus 1 and n minus 1, you can say, right, so we have reached the you can say the cell, and so the job value is equal to k also, right, and so we will return minus 1, sorry 1, right. And so this is your valid path that we are talking about. And so we can also do what some modulo operations we will apply here, and then we'll update our right and down. So we have down here we have, and right is here. So as we have said already, so I plus 1 and j plus 1, means for the right we will go to j plus 1, and for the down we will go to I plus 1, right. And with this dfs function will apply on the from we have started from the 0 0, so this is I is 0, and this is j is also 0, and we'll keep moving all the directions, and we'll return we'll keep also do the modulo. Each time we will do modulo, so that the value will be have it will not reach to the infinite, and we have to come way by way, right, you can say. So in this step by step, if we'll talk about, so first of all we have to create the dp, and these values should be started from the minus 1, right, and this is the initialization of the mode. But we'll create these for the initialization things, we'll do that, and we'll do initialization of here, because we'll take m and n, right, and dp16, because each cell will think that 16 is the cell total number of cell we will take, but one cell contains you can say 4, so it is 4 into 4, it is 16, you can say. And so that we will also initialize this with the minus 1 of this dp, and this is the dfs will start from 0 0, and so that this is your grid, and this is your job value, and this is your you can say k, and this is I and j that you can see also here in the dfs, right. And this condition we have already talked about, means first of all we'll do the initialization, where we will initialize the grid dimensions that we have talked about, right, and then we'll create a memoization function dp, right, because if we will not create it, where we will store that, right. And so we'll also create our job value, right, and we will keep moving, because grid is less than equal to 6, we can say, right? That is the things we have given. I think you have a lot of information now, so keep digging with me and try to focus on this solution and do by yourself. Thank you guys, thank you for watching this video. I'll see you in the next one. If you have any doubt, please ping me in the comment box. Also, you can reach out to the expertfunder.com and you can fill the form if you need any training and any online classes. And on the monthly basis we provide the you can say classes. So please fill the form if you need further assistance. Thank you guys, thank you for watching this video.